Okay, so we'll be going to start with this today's session. Uh, Confirm that my screen is visible to all of you. Yes, hope my screen is visible to you.
Yes, sir.
Fine. Okay. So to start with the today's session, I have already shared the agenda for we are going to cover in today's session. So just going through the contents of this unit number 6. So we have gone through the principles of remote sensing. Then we have covered the topic about the integration about the remote sensing with the GIS and hydrological elements. How we can make the application of this remote sensing in the terms of determining this hydrological data. In today's session, we are going to start with the first point, that is remote sensing applications to the hydrology. Then we'll be going to cover the introduction about the various computer models which are available for the hydrology, and then we are going to have the demonstration about the some part about related to the rainfall runoff modeling, where we are going to see the watershed delineation using the remote sensing data. So that will be a demonstration session. Along with that, there are some free data sources which are available. Out of that, we will going to have the demonstration about one website from which you can able to download the data at free of cost. So that demonstration we are going to see in our today's session. So moving with the first point, that we need to start with this to study the applications about remote sensing data towards the hydrology. So, as we have studied the various parameters, hydrological parameters or the hydrological elements that we can able to determine with the help of remote sensing applications. So, in today's session, we are going to have the discussion about now the applications of these particular data towards the hydrological part. So, application of this remote sensing data is done in the terms of measuring and estimating the hydrological elements what we have studied in the previous session. Other elements which are monitored by the remote sensing data, like you can have the monitoring towards the soil erosion, sedimentation analysis, and the water quality parameters also. Water quality refers to what that you have studied in the terms of drinking water and sanitary engineering DWC course. There are various water qualities what you have studied, that parameters that you can able to determine with the help of this remote sensing applications. Sedimentation is going to be talk about the reservoir capacities. So you have studied about the reservoirs in water resources engineering. So their capacity determination or their capacity, if it is getting reduced with respect to time due to the sedimentation. So that sedimentation analysis that can be carried out with the help of these remote sensing applications. That is one part of hydrological parameter, that sedimentation analysis of reservoirs can be carried out with the help of remote sensing data. Then determining the water balance of the river basin. So water balance equation, that you know, the equation of continuity, whatever the water that is incoming into the watershed and whatever the amount of water that is outgoing from the watershed, that water balance equation has to be satisfied. So the study of this water balance equation in the any particular river basin, that can be done with the help of this remote sensing data, and this remote sensing is considered as a basic tool for studying and the availability of the distribution of water at the local and the regional levels. So mapping of these regions where the potential water sources are available, that can be done by the means of images which are available by the means of remote sensing. So remotely sensed imageries are going to help us in the terms of allocating, or we can say the identifying the potential zones of water resources where the different sources of waters are available, maybe above the surface or beneath the surface as well, both the things. And this water which is available, that we are supposed to allocate or distribute to the consumers, and that can be done by the means of optimized use of this water. Again, here we are going to have an application of your systems application and the remote sensing, and their integration can be going to help us in the terms of carrying out this particular process. Then High spatial resolution imageries from the satellites, these are going to provide the complete visual and the digital interpretation of the basin's landscape, then land cover complexes, surface features, flow patterns, and geomorphology to solve the various water management problems. So in the terms of any kind of water management problem, we need to have the study about the terrain, and that terrain analysis is possible with the help of remote sensing data. So the terrain analysis may be consisting of the study related to the landscape parameters, study related to the land cover parameters, various surface features, that is undulations, where are the ridge lines, valley lines, then to identify the flow patterns as well as the geomorphology. So morphological study is again a part of geological and the morphological features of the soil and the earth data that can be possible with the help of remote sensing data. Then high temporal resolution imageries of weather satellites, though it is not going to have the higher spatial resolution in the terms of determining the rainfall data. We have discussed that this remote sensing is not going to give you the accurate results, but more if you are going to cover the larger area, that means the maximum aerial content, then in that case you can able to determine the rainfall values, and that the information that can be coupled with respect to the actual rainfall data which is measured on the ground surface, and that will be going to help us in the terms of providing the valuable spatial rainfall estimations. So rainfall data, these are also observed by the ground-based radar stations, and these rainfall data are then utilized for the simulation of for the flood warning and the flood control purposes. So there is a integration of this remote sensing data as well as the ground level data or the ground source data, that is the rainfall data which is measured by the rain gauges, and by coupling these data together we can have an application of this in the terms of your hydrological models towards the flood warning or the flood control purposes. Then if you are having the knowledge about this hydrological process which are going to take place, in that case we can have the proper water supply in that particular command areas. So for that purpose you must know the quantity of water which is available, where are the locations, and what is the path of what is the path towards the water has to be supplied, or what is the path towards water has to be distributed. So when we are supplying the water from the reservoirs to the from the reservoir through canals for the purpose of irrigation, we must have the we can say the larger area that plan we must have together. And if we say the canals which are of very longer length, say 100 kilometers or 500 kilometers, so it is quite difficult for us to have the idea about the alignment of that particular canals with the help of contour canals or maybe towards the ridge canals. So this particular satellite images are these are going to have the provision where we can get the idea about the terrain analysis, and that will be going to help us in the terms of aligning these canals towards the ridge lines or maybe towards the contour lines, so that we can have the proper planning towards the distribution of waters. So the satellite images which we are getting, that aerial images, that will be going to help us in the terms of analyzing the upstream and the downstream uh, terrain areas which can be useful for the purpose of supplying of the water or the distribution of the water. Then remote sensing, when we are going to have an integration with this GIS, these are going to provide the inputs to the various hydrological models. This is very important part. We are not only going to rely only based on the remote sensing data, but always it is integrated with the GIS. That is going to help us in the terms of developing the hydrological models on both regional as well as for the global scales. For modeling purpose, you are going to require the land data as well as the hydrologic data. So their interaction, then geomorphological information, and on the land surface cover, soil texture, soil moisture, topography, These are going to be provided by the remote sensing. And for modeling of the atmospheric hydrological interactions, you need the meteorological data like surface air temperatures, humidity, radiations, which are also provided by the remotely sensed data. Now, when we are having all such data together, we can have an integration or the coupling of all these data that can be help us in the terms of developing an hydrological model that will be going to simulate the runoff which may get generate out of these particular parameters from that particular catchment areas. So that is what the basic application what we can able to have with respect to this remote sensing data. Along with that, we can have the various applications of this remote sensing in the terms of irrigation and the drainage purposes. Like we can have the mapping of the irrigated lands, irrigation managements, then water logging, crop water requirements, crop water stress, salinity determination, etc. So in not only in the terms of hydrological model only, but along with that we can also have an application towards the irrigation management. Then these remotely sensed data or these images, these are going to be supplements to the topographic, geographic, and the hydrometric informations. Then these are going to be used in the terms of common small scale projects like runoff water harvesting, flood spreading, or the groundwater recharges. So with this advanced enhancements into the remote sensing technology through high resolution sensors, it is expected that this remote sensing will be going to provide the comprehensive inputs that will be going to permit the model simulations solely based on the remote sensing data. So various applications are there in the terms of hydrological use by the means of remotely sensed data along with the integration of GIS. And as we have discussed in the previous session, that now we are having an emerging technology that is of drone surveying, that is also a part of your remotely sensed data. These are also going to be used in the terms of developing the various kind of maps, topographical maps, terrain maps. Again, along with that, land use, land cover data sets that can be also developed with these images that has, these are captured by the drones. Okay, now we are going to move towards the next important part, that is the computer models for the hydrology. Now what we have discussed till now, that is generalized applications, but we must know what are the various sources which are there. These sources which are going to provide the computer models which can be useful for the purpose of study of hydrology. Now there are various, or we can say the number of computer models that are developed by the uh, various agencies for the purpose of study of the hydrological parameters as well as the hydraulic parameters. So the main developers who are involved in this particular model developments, these are enlisted here. Like we are having the hydrologic element centers, HEC. You must have heard of, you might have heard about the some software like HECRAS. HECRAS is which is developed by this hydrologic engineering center, that is HEC, and other departments of US Army Corps of Engineerings. These are also involved in the terms of developing the various hydrological models or hydraulic models for the purpose of study. Along with that, we are having the US Geological Survey Department, that is USGS. These are also going to have the various hydrological models. They are also going to provide the data, so remotely sensed data for the purpose of hydrological models. Along with that, we are having the NRCS, that is Natural Resource Conservation Services. They are also going to provide the various kind of models which are applicable for the purpose of study. Then National Weather Services, NWS, US Environmental Protection Agency, that is EPA, and many universities and the private enterprises, these are also involved in the terms of developing the various hydrological models which are used for the purpose of study. So the models of hydrologic phenomena that have been developed very related to the watershed hydrology, statistical hydrology, the river hydraulics, or reservoir planning and the analysis, coastal models, flood models, or the drainage models, etc. So we are going to have the discussion about what are the different models which are available for us to have the various study purposes, maybe in the terms of watershed, statistical analysis, river hydraulics, etc. So we will see one by one how we can have the use of these particular computer models in the terms of developing these particular uh, uh, features and how we can have the use of these particular applications. First, we will start with this uh, watershed. Like here, we have discussed various hydrologic phenomena that these are discussed. So models from this all these categories can be applied to the study of floods when it is used with the maximum storm data. So everywhere we can have the application of this remote sensing. Okay, we will see one by one all these hydrological phenomena, and with respect to that, we will discuss what are the various softwares or the models which are available that we can use for the modeling purpose. First, we will start with the computer models which are used for the purpose of watershed hydrology. First one. So watershed models, these are primarily going to include the components of rainfall and runoff correlation. You have to remember this thing, rainfall and runoff correlation. Along with that, we can also have the study with respect to the overland runoff study. Means we are not going to talk about the uh, groundwater, but we are talking about the water which is flowing over the land surface. That is overland runoff. Along with that, flood routing. Flood routing is something where we are supposed to have the application of this data towards maintaining the flood within the given duration or with respect to the given area. That is a routing which can be carried out at how much amount of water that has to be discharged from the reservoir into the rivers. So that routing process that can be also done with the help of this data. So there are various models, many models. These are going to combine with the water quality aspects and sediment discharge as well as the soil and the crop processes. Watershed hydrological, if you are going to study, so these are basically going to fall into the two groups. One, it is called as the event oriented models, and the second one is called as the continuous simulation model. So when we are going to say the event oriented model means what? Say uh, for a single day for a particular time duration there is a rainfall, maybe for say 2 hours or 3 hours of duration out of 24 hours. Now when we are going to consider the day span within that 2 to 3 hours of span, we are going to consider that is an event, that is a single rainfall event. Okay, so we can have the study of that particular single rainfall event that will be considered as an effect of single storm, so which is called as a event oriented models. That is a single rainfall event. Or the second category is that is the continuous rainfall event. Continuous rainfall event is what? Where we can have the study with respect to a longer time span. Okay, longer time span. So it is called as a long term simulation process. Say if you are going to have the study of say last uh, 40 50 years of data and you are supposed to have the study, you have to carry out the study for that 40 50 years, so that will be considered as a long term simulation. Not only that, again you can also consider 1 year of time span, that is consisting of 365 days. Out of that, for how many number of days there is a rainfall, so you can consider the monsoon time span. So that monsoon time span, again it will be considered as a long term period. Reason being, there is a daily variation, there is a hourly variation, there is a minute to minute variation into the rainfalls. So depending on that what frequency you are going to select for the purpose of study, according to that you can relate this particular term of long term simulation with this with respect to the available data. If you are having a daily data, again you can consider the monsoon period, daily rainfall data. You can consider the long-term period, that is for the duration of 4 months. So that will be carried out based on the continuous simulation models. So it will be going to include the multiple storm events. Okay, multiple storm events, and also it is going to keep the track of the soil moisture conditions between the storms. This is very important parameter, reason being to analyze the infiltration parameters. Okay, soil moisture is very important, and this soil moisture parameter is taken into the consideration in the terms of carrying out the analysis of surface runoff. Reason being, when we are considering the continuous rainfall events, at that time it may happen like yesterday there was a rainfall, so today our soil must be consisting of some amount of moisture into it. Now again, if today there is a rainfall, what will happen? Already if moisture is present into the soil, there is very less amount of chances, or we can say the very less amount of water that may get infiltrated than the water which is infiltrated yesterday. Okay, so there is an effect of soil moisture towards the infiltration parameter, and that is the very important thing that we need to consider during the continuous simulation model, and that can be carried out using this remote sensing data. So these are the two types of models which are available when we are supposed to carry out the study of watershed hydrology. Now, to carry out these studies, there are various softwares which these are available to carry out this particular study. So for event-based study, or maybe toward the continuous simulation models where there are various models, first of all we will see related to the first category, that is event-oriented models. So there are some popular event-oriented models. These are used most commonly for the study purpose. The HEC GeoHMS. Okay, this is developed by the US Army Corps of Engineering Hydrologic Engineering Center, that is HEC. Okay, so this is one of the event oriented models, means for a single rainfall event you can have the study about the how this is going to behave, that behavior study that you can able to carry out with this HEC GeoHMS. Then there is a technical release software which is called as a WinTR20 program. This is done by the NRCS, that is National Resources Conservation Services. So this HEC GeoHMS, which is developed by the US Army Corps of Engineers. So this is not only going to provide the unit hydrograph, hydrologic and the reservoir routing options which are similar to the HEC one, but along with that these are also going to provide the linear distribution of runoff transformations that can be applied for the graded radar rainfall data, continuous multi-layer soil moisture simulations, and versatile parameters of optimization options. So this is going to talk about the event oriented. There are so many softwares, but these are the popular models that can be used. Now talking about the second, that is the which continuous simulation models. Again, there are some popular continuous simulation models that we are going to discuss here. Okay, the recent one what we are able to see here, which is very we can say the popular one, that is called as a graded surface subsurface hydrological analysis model, which in short which is called as a GSSHA. Now what is this graded surface subsurface hydrological models? In the terms of continuous simulation models, I can also distribute this again in the terms of parameters. I can say it is a lumped parameter, then quasi distributed, and fully distributed. Fully distributed. Okay, so say there are three classes: lumped, quasi, and fully distributed. Now when we say the lumped parameters, what we are going to see, if you are having any particular catchment, and if there is a rainfall data which is there for the one particular rain gauge station, we are going to consider, we are going to assume this data which is for this particular data as a lumped parameter data. Or we can say if any particular watershed, if it is available with us, and say some soil parameters are available, like from various locations soils are going to get vary, so we can have say like an average value that we can able to apply for this particular watershed as a single value, that will be going to consider as a lumped parameter models. Now in quasi distributed, what we can do is, and in this particular lumped model, what we can say, like if you are going to have this river. So in this particular river, when we are going to carry out the study about this runoff, so that will be measured at the outlet point only. Okay, so that we can say the lumped parameter model, and the discharge is measured at single point. Now in the terms of quasi distributed model, what we can say, if we are having say any particular watershed and there is a river network, so in that case we can distribute this watershed into the smaller sub watersheds. Like if I will consider this first one here, for this small tributary I will consider this small area, and I will measure the discharge at the outlet of this small tributary. Again, for the second tributary I can distribute this smaller area, I will measure the discharge at the second outlet. Then I will measure the smaller area, and I will measure the discharge at this outlet. And at the end, what I'll be going to do is I'll be going to summarize all these discharges which are at various outlets, and combining them at the end, what will be the runoff. That runoff I can calculate. Now why we are going to do this? Because if I will going for the smaller areas, the parameters what I need to consider for this particular region, that I will be going to have the restricted parameters, means we are not distributing the same average value towards the whole catchment area. Means if you are going toward the smaller parts, you are increasing the parameters into this, and that is the beauty of this particular models. Now lumped parameters are going to provide you little bit average results, means these are not that much accurate. But if you are going for the quasi distributed, you are going to get the little bit accurate results which are actually observed on the nature. And over and above that, we are having the next one, that is called as a fully distributed hydrological model. Let me clear this, I will give you the idea about this. So if you are going to consider any particular catchment, say this is the catchment, we are having this river passing through this catchment. So for this particular catchment, if I will be going to distribute this catchment into the grids, just like your graph paper, or the you can say the pixels. Okay, if I will be going to have this small grid like structure, so what I will do is, for one single pixel or this particular grid, small grid, I will apply all the parameters to this. Like soil parameters are different for this single grid, rainfall data will be different for this single grid, or some hydrological meteorological parameters that may be different for this particular area. Along with that, we can also consider the land use and land cover parameters. These are also going to be different for this particular area. Now I'll be going to calculate the discharge for that single grid. Okay, for that single grid. Similarly, I'll be going to have the number of grids in this catchment area. For each and every grid, there will be individual calculation for the runoff. At the end, when we are going to have the simulation about the runoff data, as we are applying these various data sets for the smaller grids, the runoff which is calculated by that particular single grid will be the more accurate one. Okay, because the parameters what we are applying, these are actually related to that particular smaller area or that particular smaller grid, not will be, it will not be an lumped parameter. So accuracy in the terms of prediction of the runoff data, that is going to be increasing. That is the reason recently we are utilizing these the fully graded data, or the fully we can say the fully distributed data sets, and this is the software, or this is the model which is called as a gridded surface subsurface hydrological model. Here we are going to form the various grids, and in that we are going to develop the data sets. So this is falling under the category of continuous simulation model data sets. And again, one more important thing is that here in this model, we are not only going to talk about the surface hydrology, but along with that, we are having the subsurface hydrological data sets. Okay, so study of the surface and the subsurface parameters that can be carried out by the use of this particular model. So developing agency is USAC, and this is the latest revision that is released. We are having the recent version in the year of 2019. This is updated one. Actually, this is old data. So distributed parameters, single and continuous rainfall data sets, and various information that can be used by these particular models. So this is about the one type of a model. Along with that, there are various models are there, like watershed modeling system, which is called as a WMS. Okay, in short, this is the WMS. Then we are having the National Weather Services river forecasting system. Then we are having the stream flow synthesis and the reservoir regulation, simulation of the water resources in the rural basin. Like that, we are having some other models as well. The short forms of all these are enlisted here. You need to remember these short forms. Along with that, you might have heard about the mod flow. This is also a very popular software for the continuous simulation. Precipitation runoff modeling, PRMS. This is developed by USGS. Then GS flow, hydrological simulation program in the Fortran code, that is developed by USGS, IPA, and together. We are having the storm flow management model. This is also a very popular model, SWMM, which is developed by Environmental Protection Agency in the year of 2005. So this is also useful for the purpose of uh, study in the terms of design of the storm water uh, pipes, or the stormwater pipe, design of a stormwater drains. So for that purpose, this SWMM software is most commonly used. So many of the hydrological parameters, hydraulic parameters, not hydrological, but hydraulic parameter, these are studied by this stormwater management model. Then semi-distributed land use based runoff process, SLURP. This is developed by NHRI. There is National Hydrological Research Institute, Canada. Then snow melt runoff models, SRM, that is developed by NMSU, New Mexico State University. So if you are going to consider, we are having the listing of some of the models which are applicable at global scale. Not only we are talking about the regional scale, but there are some models which can be used for the global scale. So this snow melt is also going to result in the terms of runoff generation. So the areas like Himalaya, we can consider this such kind of models for the prediction of runoff in that particular regions. Their features are also enlisted. You just go through these features, that will be going to help us to get an idea like where we can have an application of this particular type of models. So this is the first thing what we have discussed about the watershed hydrology. Now we are going to have the study about the second parameter, that is the statistical models. So the statistical models, these are developed based on the probabilistic distribution. This is a very important part. You have studied the statistics in your school days, college days. This statistics is used here in the terms of probabilistic distribution. So if you are having the historical data for a longer time span, that historical data can be used for the purpose of study. So this will be going to help us in the terms of prediction. Like if you are having some historical data, that will be considered as like when this much amount of rainfall is there, this is what the runoff which is getting generated. Now there is a relation that we can generate based on the data which is available, and according to that we can develop the future prediction data sets. That is nothing but the probabilistic distribution that can be also carried out, and that will be a part of your hydrological study or the hydrological model. So HEC, they have formulated the multilinear regression program, that is MLRP, and HEC4 monthly stream flow simulation models. These are a part of your statistical models which are used for the measurement of flood or the runoff. Then MLRP utilizes the regression analysis. So you have studied about this term called as the regression analysis. This is used to determine the relationship among the rainfall and runoff parameters and the basin characteristics. HIC4, this is going to perform the analysis of the monthly stream flows at the number of interrelation stations to determine the statistical characteristics like mean, standard deviation, and the skew coefficients. Actually, this is going to be required when we are going to compare your results with respect to the calculated or the simulated data and the observed data. And for that purpose, this analysis, to carry out this analysis, these statistical models are going to help a lot. So this is what we are going to say, that is towards the verification, or we can say the results. When we are having the results with you, software results, and you are supposed to compare these results with the observed data, the for that purpose you need to have the statistical models study. That is very very important. So using the historical data, the models can also generate the sequence of hypothetical stream flows for a station with the same statistical characteristics as historic data and include the random component. So as I said, if we are going to carry out the historical study about any particular location, and if you are going to build, or if you are going to develop any particular relationship between the amount of rainfall and the runoff which will be getting generated based on that, so that formula, or we can say the empirical relationship, you can utilize as a study of statistical model to predict in the future, like if the same amount of rainfall will be there, approximately in a similar manner of runoff may get generated in the future. So that kind of model we can develop with the help of these statistical models. That is the second one. Now we are going to see what are the hydraulic models are there. Various hydraulic models that you need to understand. We have discussed now statistical, then watershed, these two. Third one is the hydraulic models. So hydraulic models, these are going to simulate the flow through the channels, pipes, culverts, and other hydraulic structures. In mechanics of fluid, you have studied about the open channel flow. So this study is nothing but a part of your hydraulic parameter studies, and this is the hydraulic mod. These are the various hydraulic models. These are considered towards the practical application. Now, when we say the channel is going to be called as towards the canals. Then pipe flows. Then pipe canals are there, then culverts and other hydraulic structures are also there. So to carry out the study of flow for these various hydraulic models, we can use the these various models which are provided. So models, these are going to determine the flow dynamics, like they are going to have the study towards the surface profiles, head and tail water elevations, and the pressure gradients. And here are some of the list of softwares which are most commonly used and accepted for the hydraulic models. So you must have heard about this very familiar or the very famous software which is called the HEC-RAS or the HEC2. These are the some of the software that we know. Along with that, SWMM, then flood wave. These are some of the hydraulic model softwares. These are used. HY8, this is also one of the part of WMS extension, which is also used for the part of study of hydraulic models. So these are some of the accepted models that you can go through it. Fourth one, we are going to have the discussion about the reservoir planning and the analysis model. So reservoir planning. So when we are going to say the planning of the reservoir, that means depending on the demand and supply, we are supposed to carry out the planning for that particular reservoir. So the planning along with the analysis of the reservoir, that can be done by the means of hydraulic computer based models. So here we can have the movement of water through the reservoir and the rivers that are going to reach based on the volume based accounting procedures. So if you remember the term which we have discussed, which is called as a mass curve in the terms of reservoir. So that is a study with respect to the reservoir capacity. Okay, so this mass curve study is used, that is volume based accounting procedures. These are used in the terms of reservoir operations. So they are going to use the optimization techniques in order to make the decision with respect to the reservoir operation. If you remember in the unit number 5, we had a one problem that is a part of dynamics, where we have used the dynamic study towards the water allocation. Okay, this is a part of your reservoir operation. In a similar manner, we can also have the some dynamics programming problems, which is a part of your reservoir planning and analysis models. So what you are solving the numericals in the systems engineering or the water resources systems, which is nothing but a part of your linear programming or the dynamic programming. These are nothing but actually utilized in the software models. Okay, you are solving the numerical here either manually, but this is what we can say the restricted way. You cannot solve, you can say like there will be a very complicated thing if you are going to consider the very larger areas or various large data sets, and if you are going to try to solve these numericals by manual way, it will be quite difficult to solve you, or you are going to take a very long time to solve such kind of numericals. That is the reason we are having the application of all such data or all such models in the terms of softwares. That is nothing but the computer based models. Okay, so these particular models, these are also going to help us in the terms of flood control, water supply, power generation, etc. So, uh, RACE PRM, RACE SIM, or HIC 5 Mod SIM, these are some of the familiar softwares which are known for the purpose of the reservoir planning and the analysis. Next, we are having the coastal models. So the coastal model projects depicts the coastline characteristics and simulate the coastline flood events. The models that can be separated in the three divisions. One is called as a coastal storm surges, then coastal wave heights, and coastal wave effects. There again, there are various softwares which are used in the terms of this coastal hydrology. The famous one that we know, that is the Mike 21, which is used most commonly. This is the software which is accepted in our India as well. uh, there is one research institute, CWPRS, located in our Pune. They are using this particular software for the study of coastal regions of our western west coast area of our India. So many uh, physical models as well as software models, these are studied and compared with respect to this Mike 21 by this CWPRS. So this Mic 21, this is a very famous software which is used in our India for the coastal studies. Then we are having the flood flow models. Again, this in this context of the flood flow models, we are going to talk about the precipitation watershed models. Along with that, there is a important part of simulation of the flood flows. Not only the discussion about the watershed models is important, or we can say the precipitation model is important, but uh, determining or simulating the flood is very, very important part. So these particular models they are going to be described based on the flooding basis, and uh, maybe depending on their natures or the task which they perform, depending on that the models are bifurcated. So first one what you are able to see here, that is the flood frequency model. So flood frequency model, these are going to perform the frequency computation on the historic flood. Like I told you, in the terms of statistical analysis or the statistical study, you are going to require the historical data, and based on that you can have the probabilistic estimation in the future. So that is nothing but the same part where we can have the prediction of the probability based flood magnitudes in the future, which is coming under the category of flood frequency models. So Hake Statistical Software Package SSP, which is released in the year of 2010, and USGS PEAK FQ 7.1, which is released in the 2014. These are used in the terms of flood frequency models. Then steady state flood hydraulic models. This is the second one. So steady state flood hydraulic models, these are going to compute the depth and the velocities or the water surface profiles along the river reach as flood wave moves from the downstream under the conditions of steady state condition or the non-uniform flow conditions. So the most commonly used software, that is a HICRAS, that is HIC River Analysis System, HECRAS. This is the most commonly used software. Along with that, we are having the USGS Federal Highway Administration, that is FHA, Water Surface Profile Models, that is WS Pro, which is released in the 1998. These are models used for the purpose of steady state conditions. Then flood flow models, in that third category is unsteady condition, and for that we are going to have the various kind of models. These are developed by the USGS, NWS and HIC models. There are various list of softwares or the models. These are available by these providers. In this case, the dynamic wave method is used for the purpose of analysis, wherein there is both continuity and the momentum equations, which are known as Saint-Venant equations. These are used for solving the or we can say the carrying out the simulation in this particular case. Okay. Then we are having the reservoir regulation models. So reservoir regulation models simulate the operation of the reservoir and the systems of the reservoir for the flood control or other objectives like water supply, irrigation, hydropower, etc. It is recalled that the routing through uncontrolled reservoir is a part of the stream flow models, and the models like HIC5 or the simulation flood control and the conservation systems, which is released in the year of 2013, that can be used for the reservoir regulation models. The next one we are having, that is the drainage model. So drainage system covers the storm water system related to the excess surface water after rainfall in the urban areas. Along with that, it will be including the sanitary sewer systems, which are related to the wastewater from the households, commerce, and the industries. Okay. Third drainage, we are going to talk about the agricultural drainage system, which is related to the excess irrigation and leakages from the farmlands. Fourth drainage system we are going to talk, that is the drainage works which are comprising the conduits or the culverts related to the roadways, airports, etc. So drainage, when we are going to talk about the drainage, so drainage is a stormwater drain. It can be a sanitary drain, it can be an agricultural drain, or it can be a drainage comprising of the conduits or the pipes or all the culverts. So Environmental Protection Agency EPA Stormwater Management Model SWMM, this is a versatile rainfall runoff simulation model used for the single event or the long-term event, that is continuous simulation models. It can develop the runoff hydrograph from the rain or the snowfall. These hydrographs, which are developed by this SWMM, these are used for the purpose of analysis and the design of the storm sewer network. If you remember, I told you this SWM, which is going to be used for the purpose of hydraulic parameters most commonly. When we are having the relationship between the rainfall runoff, this runoff which is generated based on that hydraulic parameters that can be used, which are used for the purpose of designing the storm waters or the storm sewers. This will be done by the means of this SWM, that is storm water management model. So there is a combination of hydrology plus hydraulics that is done here in this SWM. So it can model the runoff pollutants as well and the treatment of sewage through the system. So various applications of this SWM are there, can be coming under the category of drainage models. Along with that, you might have heard about there is a package of Bentley. Their hydraulic and hydrology solutions, these are going to provide the multi-platform interoperated hydraulic and the hydrology tools for the purpose of mapping, planning, optimization, designing, and operating the infrastructure which are associated with the water distribution. So you have studied about the you have heard about the various softwares which are coming under the package of Bentley, like water distribution component. If you are going to consider, in that we are having the water cad, then water hammer, Darwin's Calibrator, SCADA Connect, etc. So various, we can say the integrations. Water James is also one of the model that some of the students they have selected this Water James as a their skill course. So this is again a part of the drainage model coming under the category of water distribution component. Then in this same package, we are having the sanitary sewer components like sewer CAD or the sewer James. Then for the stormwater component, we are having the storm CAD, civil storm, pond packs, culvert master, flow master, etc. These are various kind of models. These are coming under the heads of this stormwater component. So this is what about the various models or the software packages which are available or which are used in the terms of study of hydrology and the hydraulics part. Okay, now we are going to have the demonstration part related to the rainfall and runoff flood flow models. But before going for these rainfall runoff flood flow models, I'll be going to have the demonstration about the free data sources which are available. Okay, I hope you guys are with me. So I'll be going to give you the free data source where you can download the remote sensing data. Okay, so please note this link. There are so many links are available from where you can able to download these data sets. But the very famous or very well known website which is providing this remotely sensed data at free of cost, that is USGS Earth Explorer. So if you are going to search on Google Earth Explorer USGS, you are able to see this earthexplorer.usgs.gov website. You have to click on this Earth Explorer USGS. Just give me a moment. Okay, so this is what the window what you can able to see. This is the dashboard of this USGS website. So various data sets that you can able to get, this remotely sensed data sets that you can get from this particular websites. Okay, so for that to download this data at free of cost, you need to create your account. You need to log in, and then only you can able to uh, get this particular data. So if you are not having your account, you can just put your login details and you can create your own account to download these datasets at free of cost. Now I'll be going to tell you the process and how we can get the various kind of datasets that I will be going to explain you. So in the window which is there on my right hand side, you can able to see there is a map. Okay, so for all over the globe, whatever the data set or the regions you can select, for that particular region you can able to download the data. Okay, so we are interested for our India obviously. So for that particular area we are going to find out the data, whatever the data which is available for us. Okay, now what are the things you need to do? First thing is that there is a four tabs what you can able to see on the left hand side. First one, there is a search criteria. Search which is for the allocating the location for which you wanted to identify the data. So search, here you are supposed to provide the search criteria, or you can also directly select the location on this particular map and you can get the data for that particular location. There are processes that you can follow. You can draw a polygon also here. You can draw a circle, or if you are having the predefined data, for that data you can get the various kind of maps or the images which are available, which are provided by the remotely sensed data sets. At the end you can able to see here the date range is given, for which date you want this particular data sets, that you can select and accordingly you can search for the given data. Okay, so here I'll be going to select one random data set. We will see. if you are able to get this particular data or not. Let's see. uh, First of all, we are supposed to select the search criteria, so I need to provide the location. Right now I have not provided any location, so there are no coordinates selected. You can see this particular message. So I'll be going to click on the data set for the say Pune region. I'll be just going to click here. So you can see the coordinates for this particular location, these are available. Now here you can put your the coordinates manually if you are knowing. You can also use the map, or you can remove the coordinates here. So I think I will be going to provide only one coordinate, and for that coordinate, whatever the data set which are available, I will use map for this particular location which are available, and accordingly I will search for this. So this data will get selected. Now these are the boundaries for which the data I can get. So if you see the area which is covered, this is very large. If you are going to see in this case, there will be various, we can say, number of grids. These are going to come in this particular area, and the topo sheets will be very number of topo sheets that you need to add here. Okay, many number of topo sheets that you need to add here. This is one thing that I have provided the data. Now next thing is that I need to check for the data sets. Second thing, that will be the second tab. So here you are able to see the various kind of remotely sensed data which are available here, like aerial imagery, the declassified area, digital elevation, digital maps, global visual, then land cover data sets, Landsat data, then we are having the radar data, ISRO resource gas data, like various kind of data sets are available. For the purpose of watershed delineation, which we are going to demonstrate, for that purpose we are going to require the digital elevation models. Digital elevation, it refers to the simple thing is that digitally information is stored in digital, elevation data is stored into the digital format. That is so the simple meaning of digital elevation. Okay, so you have heard about the term called as a DEM, that is called as a digital elevation model. So this is what the image actually, this is not a model actually, this is an image. This image is going to be consisting of elevation data stored in a digital format. Okay, so that kind of data is required for the topographical study or the topographical analysis. If you want to build the contours, if you want to find out the ridge lines or the valley lines, this is done by the means of this digital elevation data. Okay, so here again there are various categories. Out of this, I'll be going to select this SRTM wide field data. There are various kind of data that you can search for. So I'll be going to have this non-wide field and the wide field data sets, and we'll see if you want to provide some additional search criteria, you can provide it, or at the end you can see for search for the results. If the data is not available, it will show you no results found. If data is available, it will be going to show you the results for this particular location. So here for, I think, the data sets or the search criteria which we have provided for that particular date, the data may not be available, so we will put till 2022 first. So for this we will see the results. Again the data set is not available for this. Let me check. Two thousand and one. I guess some data sets are removed from this particular source, but this is what the process actually, though actually this is what the free data source. Maybe because I have not signed in right now, the dataset may not be available for me. I have to sign into this account and then I can able to search for these datasets. That can be one security that they have provided. Along with that, if you are interested for the datasets which are used for the India, so you can search on the Google, search, type the name Bhuvan. Okay, So you will see there is one website called as https://bhuvan.nrcs.gov.in. Okay, nrsc.gov.in. So this is our Indian Space Research Organization ISRO. They are providing these particular data sets at free of cost. So you can also search for these particular websites, various uh, types of data sets which are remotely sensed data. These are available on this particular websites. Okay, so you can just go through this website also. You will able to get the various maps. So you just need to go to the thematic services, and this under this thematic datas you will find again there are such criteria: statistic, analysis, metadata, web services. So that particular datas you can able to get here. I need to check for the grids. Let me check if I will able to see. Here you can able to see the various categories like land use, land cover data sets, then wasteland, glacial land, limestone, flood hazard, flood water bodies, urban sprawls. What you can able to see that you can able to get the data. So here land use, land cover 50K 2015-16 that we will see here, or say for the Maharashtra. So here you can see the technical documentation, maps, and the statistics. We'll see keep on view. So here you can able to see on the right hand side. This is the data what I can able to get from this Bhuvan website. Okay, this is the data which is available for our India. And here whatever the color codes are there, you can able to see this red color wherever you are able to see this red. This is going to show you the built up. Again, little bit brown. This is built up rural. This green color what you can able to see, this green color is going to show you the forest evergreen. Yellow color is going to show you the agricultural land. Blue color is reflecting the water bodies. Okay, then there are various categories are there, and accordingly you can able to see the land use, land cover, they are categorized. Okay, so this is what the data which is available on the website of Bhuvan that you can calculate get from this. And their details are also available like coordinates, how much area is covered, and all these data sets that you can get from this particular Bhuvan website. So this is again the free of cost data source that you can able to see from the NRSC, National Remote Sensing Center, which is located in Hyderabad. They are providing this particular data sets at free of cost. Okay, like here some of the data sets if you are interested for, like to search for the reservoirs and lakes, rivers, that also you can get from this. Like here if you will search, just zoom in a little bit slowly, it's taking time. So it will be going to show you this river paths. If you are able to see this is the river path which is Bhima river. Okay, which is passing all over the Pune region, or this Pune district. Likewise, you can get most of the data here. For transportation data also you can get administrative layers that you can mark over here in the same maps. So whatever the information you want, accordingly you can increase the data sets here. 1516, I will just remove this. Fine. So the number of districts that you can select, and accordingly you can search for the various data like this. Now I have selected for the Tamil Nadu, so you can get the data for the Tamil Nadu region as well. Okay, so this is how you can get the data which is available at free of cost. Only thing is that the data which is available at free of cost, it is of not the required resolution. Means if you want the higher resolution, in that case you need to purchase the data. The data which is available at free of cost, this is of a little bit we can say the less resolution image which are available. Like if you are going to say compare with your mobile camera, so the VGA cam and the 21 megapixel or 164 megapixel 121 megapixel cam, you can compare the image resolutions. That is what we can say, the VGA quality image that can be available at free of cost. And if you want to go for the higher resolution images, in that case you need to purchase it. That is what about the free data sources which are available. Along with that, there are so many, we cannot compile it in a very short span. The next thing is that now we are going to have the demonstration about the watershed delineation using this remotely sensed data. So for that purpose, we are going to use the digital elevation map DEM, and we are going to have the demonstration about watershed delineation for the Koina reservoir. Okay, so we are going to use this software called as a QGIS, Quantum GIS, for the demonstration about this digital elevation map. So uh, your classmate Nishan, he is going to demonstrate you about this particular watershed delineation using QGIS model. Okay, so I will hand over the platform to Nishan to demonstrate about this watershed delineation process, which is required as a basic part for the sake of you can say the basic important requirement for the hydrological models. And for that purpose, this watershed delineation, this is the basic process that you need to carry out. Fine. So over to Nishant. Nishant, you can just start with this session and continue with this. Just wait for 5 minutes till this particular platform is starting. I will be starting with the demonstration in few minutes. Till this particular QGIS is going to start, I will be going to tell you about one more package, that is package of WMS, Watershed Modeling System software, where I have explained about this the graded surface subsurface hydrologic analysis model datasets. So for that, you need to search for the Aquavio, QUAVEO. So here you will be going to get the various packages of softwares models which are used for the hydrological study. This is a software package of WMS. So here you can able to see the groundwater modeling system, GMS, surface waterological modeling systems, SWMS, then WMS, watershed modeling systems, arc hydro groundwater, city water, etc. These are the package of the softwares which are available under this Aquavio. So if you will go to this watershed modeling systems, so here you are having this study related to the hydrological parameters. Okay, so determination of flow paths, this mesh generation, what I told you about these grids, everything that you can able to study under this particular uh, area. Here this is what you can able to see. This is the 2D distributed hydrology. Distributed refers to the grid formation. So here you can able to see the grids, these are going to get formed, and the water flow, how it is going to take place over this particular topography. That analysis you can carry out under this package of the WMS. Here you can download the free trial of the software package. You can utilize this particular package for the 21 days at free of cost. Okay, so this is there are various versions of software packages are available for WMS. Along with this, that if you are interested for the study, you can go under the downloads option. Sorry, for the tutorials, you can get the tutorials here under the head of learnings. So for here you can find this WMS tutorials. So the dam delineation, this particular component, dam delineation, that is watershed delineation part, that is what the part Nishan is going to demonstrate, but he is not going to demonstrate using WMS, he is going to demonstrate using QGIS. But under this package of the WMS 11.1, again you can carry out the same processes. WMS hydrology, here GSSH, yeah, this is what distributed hydrology. You will find this application of GSSH. This is going to be used for various purposes like land use land cover change. Then you can use it for the long-term simulations. You can utilize it for the simulation of sediment transports, then overland flow hydrology, snow melt modeling. Along with that, you can also go for the calibration. Groundwater modeling is also possible using this software package. So you can carry out this GSSJ, which is used for the distributed hydrological modeling, and along with that, you can also have the means this particular WMS is going to have the package of another softwares also. Like I told you, hydraulic and flood modelings are there. So like HICRAS, floodplain delineation, etc., HY8 modeling. These are the various models. These are available under the WMS package. SWMM, this is also one of the package for the storm drain sanitary receivers. Water distribution modeling, EPANET software is there. Water quality modeling, HSPF and CQAL. These are the software packages. These are available under this particular WMS. So if you are going to download this WMS, you can carry out the various processes or various modelings under this particular one head. This is the beauty of this WMS. Only thing is that the software is not available at free of cost. Okay, for that, for this particular software package, again the data set which is required, this is the remotely sensed data, that is the requirement for this particular package. Okay, hope so this QGIS has started.
So I hope the screen is visible. QGIS just took a little time to start. So sir just explained about what hydrological models and all are computer-based models. And sir also mentioned about WMS. WMS is actually specifically used in hydrology to play with the data to extract and modify and employ various processes in hydrology. But this particular software, QGIS, is for all kinds of data, not just in hydrology, but in varied sectors. You can create all sorts of maps and extract input data and create multiple kinds of data from the software. So hydrology is just a small part of it. So we can also use this for hydrology as well. Just a minute, I guess. Yes.
Students, I guess we are facing some technical issues for running this software as we are working with this MS Teams. While sharing this QGIS, it is not responding properly. So for that purpose, what we are going to do is we will be going to make a recorded video in next 20-30 minutes. That recorded video, I will be going to share it with you so that you can go through this demonstration how the watershed is delineated using this QGIS. This is just because of this technical issue of sharing this screen during this MS Teams platform. Okay, so just excuse for that, but definitely this demonstration part, a recorded video, I'll be going to share it with you within next half an hour. Okay, so stay tuned for this updates of recorded video. Regarding today's recorded session, again I'll be going to provide the link of recorded session to you. You can just go through this recorded session for your final examinations. Okay, so that's how we are going to conclude here for the unit number 6. Just take me give me a minute for downloading your attendance for today's session. Okay, so thank you so much for attending this session and all the best for your final examinations. So we are going to stop here. Have a nice day. Take care. I will share both the recordings in a while.